Hello, everyone. This is Gus Rodriguez. I'm part of Group 18. We were responsible for the dashboard module, part of a multi group project for a content creation pipeline for the U.S. Navy. Our group consisted of Duncan McKinley, myself, Gus Rodriguez, Louis Spires, Roberto Napoles, David Redravon. Thank you.
Hello, this is Roberto Napoles from Group 18. I'm going to talk about the goals, requirements, and constraints of our project. The primary goal of this project is to build a dashboard model for the content creation pipeline, a system envisioned to manage and store the United States Navy extensive training materials and manuals. Specifically, the project focuses on connecting the message broker system, establish seamless integration with the backbone of the pipeline, enabling communication between individual models, sending and receiving messages, implementing functionality to both send and receive messages throughout the message broker, ensuring the dashboard plays an active role in data exchange, designing an intuitive front-end interface, creating a user-friendly display that presents a clear and accessible view of the message broker system's activities and data. These goals ensure that the dashboard model acts as a central interface, empowering users to monitor and interact with the system efficiently. To meet these goals, the project comes with specific technical requirements. The dashboard model must be fully integrated with the message broker system, serving as a vital link in the broader content creation pipeline. The project is entirely server-based, leveraging cloud infrastructure for scalability, reliability, and accessibility. By adhering to these requirements, the module will ensure compatibility and efficiency within the largest system architecture. While pursuing these goals, the project is bound by certain constraints. Front-end framework. The dashboard model's interface must be developed using a front-end framework to effectively visualize and display information about the message broker system. Deployment using Docker. For consistent and portable deployment, Docker will be used as the containerization tool. Messaging with RabbitMQ. RabbitMQ will serve as the messaging tool, ensuring reliable message delivery and robust integration across the system. These constraints establish the technical boundaries within which the project must operate, ensuring uniformity and ease of implementation across the modules.
Hi, my name is Gus Rodriguez. I'm part of Group 18. Today I'm going to be discussing our product design, implementation, and testing decisions, um, and how that evolved into the final product that we delivered. Our team approached the design phase with a focus on creating a scalable, real time monitoring solution that could effectively handle the Navy's content processing requirements as provided to us by our sponsors. Ultimately, the design consisted of four main components. First, the presentation layer, the front end itself, was a React based real time dashboard that was very flexible and capable of providing real time updates and refreshing without any complicated development work, which made it the perfect solution for displaying the contents of the pipeline in real time. For the back end, previous semesters had implemented a RabbitMQ messaging system that would accept messages in a certain format and then handle them and hold them in there. We expanded on that by implementing a WebSocket server using Python to handle that live communication between the message broker and the dashboard. For message persistence, in order to load messages even after the application was closed and open, we went ahead and utilized MongoDB. Originally in the design process, we had tested using SQLite, but found that it was a little bit too rigid for what we needed. About midway through the project, we switched over to MongoDB that handles messages in a loose format. It's a NoSQL database, which made it a lot easier to just handle messages as JSON objects. And then finally, in order to efficiently deploy this system on any machine, we containerized all of the resources required into a Docker file, which really sped up development time and made it easier to update changes across development environments. Continuing on with our implementation, I'm going to talk a little bit about the front end, with which we built a responsive dashboard using React that includes a few key features. The real-time display uses a WebSocket connection in the background to display content on the front end. This WebSocket connection combined with React allows instant updates as new content enters the pipeline. And then our UI itself featured an intuitive job-based grouping system that makes tracking relating messages pretty straightforward. Later on in the design of our project, it was decided that we should add some analytics. This was more of a personal challenge rather than a requirement of the Navy, but we did implement some tracking of system performance, including features such as system uptime, message rate, processing rate, the throughput, the response time, how much data was being used by the client, and how many clients were connected, just as an example. And that covers our front end components at a high level. And as part of our implementation, we needed to consider how to actually store the data that we were receiving and parsing rather than just display it, because the information itself just on the screen wasn't very useful. We needed some sort of persistence. Otherwise, there's no real point in the application. So ultimately, we started testing with SQLite, which worked okay when we were just sending mock data without any real content. But through discussions with our sponsor and the professor, we discovered that MongoDB would be a better fit. And this is because it's a docu-based storage database rather than a row value pair. Essentially, the data can be stored more as an object that can be accessed more easily programmatically rather than a strict like CSV set of data. This enabled real-time data handling capabilities, and Mongo's flexibility and easy ability to spin it up easily made it very easy to just consider this a scalable solution, which we tested in our unit testing for mass messages being sent to the server at once. Continuing on with more of our back-end decisions, we ended up using Python's async.io library for efficient message handling. The code that you see on the screen shows our WebSocket server implementation, which manages client connections and message distribution. So with just a few simple lines, we were able to set that up with an existing library. We integrated the existing RabbitMQ messaging functionality for queuing, which enables reliable message delivery even during high traffic periods. RabbitMQ basically just pops messages in a queue or pushes messages onto a queue and pops them out in the order that they're processed. Including that, the MongoDB integration include optimized queries for quick data retrieval and storage, so we can just use those expected key value pairs from the other components of the content creation pipeline to quickly locate those messages in the future. A particularly challenging aspect was implementing the real-time analytics collection system. We ended up just implementing Python's psutil library to monitor system metrics, as well as queries to the MongoDB layer that are constantly being pulled back to the front-end UI for just seamless updates to that without the user having to do anything additional. Now that we've discussed some of the design and implementation decision-making process, I'm going to talk a little bit of how we tested and verified that our code was working. Very early on in the process, as I mentioned previously, we were just using mock data being sent through a Python script. No actual content because we weren't sure how the other group's components were working. It was literally just key value pairs that we would then parse out and display not in real time. It was literally just a static collection. This did evolve as we unit tested our components and were able to start integrating more of the other team's components into our dashboard. So yeah, the unit testing helped correctly to isolate individual functionality that needed to be improved while we waited for the final output from the other teams. We wrote tests for the WebSocket server, database handlers, and front-end components. As we progressed, we did some integration testing to verify that all the components worked together seamlessly, which was super important for actually showing messages in real time rather than using stock data. And then finally, performing testing helped us optimize the system's efficiency and reliability. That manifested as slamming the server with a bunch of messages at once to see how it would respond. And although there was some latency spikes, which are to be expected as it's processing messages, nothing ever crashed, and then the system was able to scale very efficiently with dozens of messages. Our performance testing revealed impressive results. The system consistently processed messages with latency under 100 milliseconds, which met our real-time requirement. We conducted extensive load testing, simulating multiple concurrent users and high-volume messages. The system maintained stability even under peak loads, with our WebSocket connections remaining reliable and database queries performing efficiently. Some key metrics from our testing: average message processing time was about 85 milliseconds. Our WebSocket server was available 99.9% of the time. Usually just spinning up and shutting down is the only time that there was any outages, which is to be expected. Database query response time was under 50 milliseconds, and system resource utilization under load, the highest I ever saw it get was 65%. So these results validated our design decisions and implementation approach, proving that our system meets the requirements for real-time content pipeline monitoring.
My name is Louis Spires, and I'm a group member of Group 18, and today I'm going to be discussing our project, the dashboard module, kind of as a whole, just making a summary now that we've reached the conclusion. So first, I'd like to kind of start off with our introduction to the actual project and the initial challenges that we faced. Our first introduction to this topic was it was pretty much a general meet and greet. We sat down with our sponsors, who are members of the U.S. Navy, and they kind of provided us with some background information. They told us that this project of theirs was going to be a proof of concept and that we would be continuing the work of another team. And so after that, they kind of gave us, well, not kind of, they did give us resources to continue the work that the other team had already worked on or put together. And that was in form of lots of documentation and a virtual machine. And the initial challenges that we faced after receiving the documentation and the virtual machine was primarily getting the virtual machine running. And so, I mean, we've come to find out that it's not a very uncommon issue that on some computers, like on some systems, the virtual machine was able to get up and running, and on others not. And so that was one of our major issues early on at the start of this project. So, given the amount of time involved in troubleshooting with the provided VM and getting things set up to work locally, we decided initially that our time would be best spent if we were to make design choices that were in line with what we as a team were familiar with. And though implemented initially, after one of our weekly meetings, it was decided that our sponsors felt it would be best if we were to incorporate features or certain aspects such as WebSockets and MongoDB, which then had to be later introduced, and so changes were made. This, in addition with the dashboard module, or our portion of the dashboard module, just being, as I said, a portion, and it was part of a bigger picture. Other teams were working on their modules as well simultaneously, so that kind of influenced our decision making to make sure that the integration would be a bit more seamless. Lastly, due to some of these changes and shifts over the duration of the project, we tried to rely on a planner tool from Microsoft, which allowed us to set tasks and due dates for various aspects of the project. Lastly, I'd like to discuss our integration with the other teams' modules, and in addition, just the project moving forward as a whole. So because of the fact that our module was separated from the other teams, so the metadata team and the image processing team, we were provided with dummy data as to how to structure our module and how to expect to read the data from the other modules. And this, in combination with one-on-one meetings, proved successful for the integration of the modules between one another. And lastly, given that we're no longer going to be continuing to work on this project, we do still hope that it continues to push forward, because we were told that this is a proof of concept and that further improvements will be made. In efforts to ensure this, we're providing our sponsors with zip files containing the latest instance of our dashboard module, README guides with clear and concise instructions as to how to get the project or the dashboard module going and its purpose behind it, as well as just further documentation. And some future features that we foresee or that we've heard are probably likely going to be introduced, likely further analytics, and possibly, depending on if they decide to upscale it, possibly parallel processing is those are some of the features that we foresee being introduced. All right, thank you.
Hello, I'm Duncan McKinley from the dashboard module for the content creation pipeline, and this is the demo. We're going to start with running the Docker container. It has RabbitMQ in it and Ollama for the machine learning. So RabbitMQ is running. We can make sure by looking at Docker desktop. Right there, all running, perfect. So now let's start our Python script with, it's got a lot of things in it. So we have our parsers, we have our node server, our WebSocket backend. This is our React front end, start that. We have the metadata as backend, and then we have a file uploader built into the site as well. So let's start that. Should pop right up. Boom. It's just loading. We're connected. It should refresh one time. There it is, refreshing one time. So I have all these messages in here right now. Let's just go ahead and clear the database out. Boom. So database is clear, should clear the site if I refresh. Boom. So no messages, we're connected. Let's go to Neo4j. Oh, wrong window. Neo4j, this is an old DB that I have, so let's just delete this. Boom, starting fresh. All right, so right now we have the front end and all this running. I'm going to leave the document module closed so we can see some of the messages that get popped up in the RabbitMQ. So let's upload a file. Let's do big letters PDF. This has 2 images in it. So we're going to send it, and we should get one message. Boom. Document file, big letters, was successfully sent to the documents queue. So there's the content ID right now. And that is it groups, and so all of these messages are going to be grouped underneath this content ID. Each job is a job ID, and each piece of media has a media ID as well. Blue for documents. These are green is for being processed. Let's go ahead and check the RabbitMQ right here. Let me refresh. So right now we have one document sitting in, one message sitting in the document queue, which is perfect. So as I run the document module, it's going to consume that message and it's going to send the dashboard and the image module a whole bunch of messages around. So it's probably going to be hard to see, but let's do it really fast. Boom. So right there, it's going to, should eat this message right here. If I ran the right thing, there it is, ate that. The document, and now the dashboard module is getting messages right now. Boom, there, it just got the big message. Image module got the message and they were stored. You can see that right there. So let's go back to our React app, and there are all of our messages right here. So color coded, status message yellow, images are purple, documents are blue. Over here, the status messages right now. So let's go from here. So as they got sent, it was processed, successfully processed in the document queue. The two images were sent to the image queue, and the PDF was had its nodes and relations. They've all been stored to Neo4j now, and we can go and check Neo4j if we want. Oh, wrong thing again, right here. So now if I click here, we can see our new database right here. So that's the file that we sent being classified. Let's go back. So then the images were sent to the image queue, and then we got messages back from the image queue that the images have been stored and classified, and they were classified as an aircraft carrier, competence that, and Canon 75. So that's all working right there. We can view our analytics down here. So this is a lot of local data right here. We have uptime, which is awesome. I let the program run for like 12 hours earlier, and I came back and saw it was running 12 hours, and it made me happy. We have network data to see like how much traffic we have, how much is coming in and coming out, the messages per second, which is really cool. It just doesn't work that well right now with not just testing like one file. You know, if we were testing a lot, and the thing is I have to go here every time if I want to test something. So this, if we're not doing that, if we just have like a constant flow, this will actually be a very accurate metric. Total files is like up here, the total messages. Success rate doesn't work properly. That needs work for sure, because we're at 100% success rate. I'm not sure why this is not working right, but I'll look into it. And average response time is extremely low because the front end isn't really processing anything. We're just displaying the messages that are being processed. So, I mean, I can upload an audio file. I can show you, go to the audio queue. There is no audio module, so this should just get hung up we should get one message, and then it should get hung up in RabbitMQ. So boom, there we go, audio file, and we go to RabbitMQ. There it is, it's sitting in that queue right there. So let me go back, and now I can see this content ID doesn't have any audio in it, and this one has one. So I can go up here to a little search, and I say, oh, I just want anything that has any content ID that has audio in it. So I just click this, and then boom, we only have the one that has audio in it. And I could also go like this. I could just take a piece of the string and do it like this, and I don't need to have the type. Let's just search it straight for it. Also, if I had more messages on here, we could show a lot of messages on the page. Let me put a bunch of messages through real fast. And this is going to take a while. We have a script that does it in the back end anyway, but so 22 messages now. It's pretty much instantaneous how these are coming through. I mean, there's no real time hang up on our end. It really has to do with the document module classifying these, the documents, which is happening right here. So yeah, right here, training set. This is really where the time is getting eaten up, but it's still extremely quick. And on Mac, it is so fast. We do have a version for Windows where you can use, this would be the script for that one, where you can use your GPU instead right here. So you would run Docker Compose with your GPU instead of that. Anything else? Let me see. That is pretty much it. Thank you so much. This project was definitely a challenge. but I had a lot of fun, and I'm very proud of what we got to, and our sponsors are also very happy with us, and I'm proud of myself. Thank you so much. Bye-bye.